With a question like number 7, what you're being asked to do here is figure out what statement is going to link acidity to anion stability. So what I'm going to do here is show you what the anions look like. So for this one, it would be CH3, CH2, CH2, CH2 minus, with the minus on the C and H plus here. And this one will be CH3, CH2, NH minus plus H plus. So these are the anions, once the negative charges. These are the initial acids or the acidic compounds that we're talking about. So the idea here is that you want to be able to write a statement that links anion stability to acidity. And in any of these cases, this is how it's going to work. In this case, I'm going to call this A. Now I'll call this A minus. Whoops. This will be B, and this will be B minus. So the premise that we're operating on here is that out of these two, the one with the N minus is more stable than one with the C minus, because the N is more electronegative than the C. And the way it would work would be B minus is more stable than A minus. Therefore, B is more acidic than A. And this will be always the way that the statement will be set up, talking about which anion is more stable and then which compound is more acidic. Now these, in the second part of a statement, are always what you start with, and the anions here will always be what you begin the statement with up here, obviously talking about which one has the greatest stability of the two. Now the way this works, or the reason it works this way, is because if this anion down here is more stable, if this anion here is more stable than this one, then what's going to happen is that more of this anion will end up being produced. That means that more of the H plus will also get produced as well. And if more H plus is getting produced, then that would be a more acidic compound.